This video is on the law of cosines. Here to the right, I have the three equations that we use for the law of cosines. A squared equals b squared plus c squared minus 2bc cosine of a. All these small cap letters, little a, little b, little c, they all refer to the sides of the triangle. And this capital letter A, this refers to angle A, or the degree measure of angle A, okay? So if you're going to look for side A, it's very simple. You square the other two sides, and you add them, just like the Pythagorean theorem. And then you subtract 2 times this times that. And then the cosine of whatever side you're looking for. Okay, of the angle that's across the side you're looking for. The same pattern follows for all the other equations. If you're looking for b, you're going to have cosine b. If you're looking for c, you're going to have cosine c at the end. And inside you'll have the other two letters. You're always working with a, b, or c, so if you're looking for b, this will be a and c, and then minus 2ac. If you're looking for c, you'll have a and b minus 2ab, etc. They're very easy to learn. Now, when do we use the law of cosines? Remember, law of cosines can be used for any triangle, but especially triangles that are not right triangles, we can use the law of cosines to solve them. Which triangles specifically that are not right triangles? Well, triangles, when you have triangles that give you this information, it gives you the information for 2 of the sides and their included angle, and we abbreviate this as side, angle, side. And notice angle is in between the 2 sides, so on your drawing, this angle should also be in between the 2 sides, and we'll see that when we start labeling this triangle. And this also works for triangles that show you the measures of all 3 sides. So we're going to do this first case in this video, and then we'll do another video where we have all 3 sides. Okay? Let's label this triangle so we can start solving it. Triangle ABC, let's start with A up here. I want to write A here, B here, and C on this corner. If A is 10, that means this side here, let me bring this down a little bit. There. This side here is 10. The side across angle A. B is 12, that's the side across angle B. And the measure of angle C is 40. Okay, we've labeled everything. Notice how this is side, angle, side, and the angle is included between the 2 sides, between these 2 sides. That's where the angle is included. So this is a case where I can use the law of cosines. So the law of cosines helps you look for the side. It also helps you look for the angles. But in this case, straight away, I have 2 sides. All I'm missing is side C. So I'm going to use this formula right here to find side C. Okay, let's do that. I'm going to use c squared is equal to a squared plus b squared minus 2ab cosine of c. Let's fill in. C squared is equal to, what's A? A is 10 squared. Plus b, what's b? 12 squared. Minus 2 times 10 times 12 cosine of angle C, which is 40. Now, in your calculator, be careful doing these steps. Remember the order of operations. So I like to solve this a little bit before I input these values into the calculator. 10 squared is 100. Plus 12 squared, that's 144. Minus 2 times 10, that's 20. Times 12, that's 240. Times the cosine of 40. And I'm going to go one step further. C squared is equal to 100 plus 144. That's 244 minus 240 cosine of 40. Now be careful here. A lot of students will take 244 and subtract 240 from it, and that is wrong. Remember, order of operations, you multiply first, and then you add or subtract. So we have to multiply this quantity first, and then you can subtract that quantity from 244. So go ahead in your calculator and hit 240 times cosine of 40, and then 244 minus that answer that you just got, okay? And you should get that C, and once you have that value, remember, you will have that C is equal to the square root of whatever you get for this value, okay? So it's going to be the square root of 60.15. That's what you should get. You take the square root, C is equal to 7.76. You found C. Once you find C, you have that side. You've completed that side, okay? Now, what else do we have to find in this triangle? And this is where we have to be careful with the cosine law. Let me fill in side C. We said, let me go back to green. Side C is 7.76. 7.76. Now, I want you to observe this triangle, the three sides. There's a side that measures 12, one that measures 10, and one that measures 7.76. Now, what's important about this? The important thing about this is that the largest side, or the longest side, corresponds to the largest angle. So this is what I mean. The longest side in this triangle is this side, side B, which measures 12. That tells me that angle B will be the largest of the three angles. That's what it means, okay? So angle B for this triangle will have the greatest angle measure out of the three angles. Angle C will have the smallest angle measure out of the three angles because it corresponds to the smallest length, which is 7 out of the three lengths, okay? So why do I need to know that this angle is going to be the largest angle? Because now when we try and solve angle B, okay, if I want to solve angle B, I have enough information in this triangle to use the sine law instead of the cosine law, okay? That's an option you have. You can look for all of these angles just using the cosine law. But once you've got that third side, you can use the sine law, which is a shorter way of finding angles or sides, okay? Now, you decide at this point if you want to look for angle B and angle A using the cosine law, or if you want to look for angle B and angle A using the sine law, okay? Now, if you decide to use the sine law, this is what you have to be careful about. When looking for angle B, which is the largest angle in the triangle, that tells me that angle B can be, I'm not saying it is, but it might be an obtuse angle. Okay? And what I mean by that is that this angle can be greater than 90 degrees. Now, if I think it's possible for this angle to be greater than 90 degrees, then I have to be very careful, okay? I have to use the cosine law and not the sine law to look for angle B. Why, you might ask? Well, because the sine, the inverse sine function, when we studied inverse trig functions, the range for the inverse sine went from negative pi halves to pi halves. So I'm going to show you here to the side. For the inverse sine function, the range or the output values for this function were found in between pi halves and negative pi halves. In radians, and if we're talking in degrees, we're talking about in between 90 degrees and negative 90 degrees, okay? That means that the inverse sine function will never output. The output here will never be greater than 90 degrees, never. So that means this function will not output obtuse angles. That's what it means. Okay? And since that's true, and I suspect that this angle being the greatest angle in this triangle might be obtuse, it might not be, but it might, I don't know yet, I'm going to play it safe and not use the sine law to find this angle. Okay? So be careful when you're trying to solve these triangles. Now the cosine law will tell me the true angle, because for cosine, if you remember, for inverse cosine, the range or the output for this function was from 0 to pi, or from 0 to 180 degrees. So this function will output. It will output obtuse angles. Obtuse angles. These angles can go from 0 to 180. Okay? These will not be greater than 90. So when looking for that angle that you suspect can be obtuse because it's the largest angle in the triangle, do not use the sine law. Use the cosine law. Okay? So that's something that you have to be mindful of. Okay? And there's another way to approach this. Let me erase this here. You can go back later and check it again and try and understand it. I hope you did understand that. Okay? Now there's other things we can do here. I don't have to go and solve angle B. I can solve angle A, and there's no problem here. This is not the largest angle, so I can use sine to find A. And there's no problem, okay? But be careful. Keep this in mind. Let's go to A, okay? Let's look for A using the sine law. So I can write A sine of A equals C sine of C. A is equal to 10. Sine of A, which is what I will look for, C is equal to 7.76. And sine of C, which is sine of 40. Okay, so to solve for sine of A, I'm going to cross multiply that way and this way. On this side, I have 10 times the sine of 40 equals 7.76 times the sine of A. So I will divide both sides by 7.76, and the sine of A is 0.8283. So that means that the measure of angle A is equal to the sine inverse of 0.8283. Measure of angle A is equal to 55.93 degrees. And I can say that's approximately equal to 56 degrees. Okay? That's the measure of angle A. Let's write it here. Approximately 56 degrees. Now to find the measure of angle B, well, that's very simple, right? The measure of angle B is going to be 180 minus 40 plus 56. And that will give you 84 degrees. And there you have it. Notice that angle B, which I suspected was an obtuse angle, is not an obtuse angle. It's really an acute angle, but it is the largest angle in the triangle, okay? So there you have it. This example we could have done using the law of cosine for the whole thing, but the sine law makes our life much easier. So I didn't use the law of cosine. I used the law of sine, but being very careful to use it on the angle that I know is not obtuse, okay? So I went and used it with A, and then just adding and subtracting, I got B. Go back and study this again. Make sure you're very careful here, okay? I'll do another example with law of cosines using when we have the case where we have all three sides. I'll see you in the next video.